Okay, so today we'll see the unit 2 of forensic chemistry. We will start, and in this unit, we are going to study about fire, how fire works, what is the forensic significance of fire, and also we would start looking into the examination of cases involving fire accidents or intentional setting of fire, that is arson cases. So let's start by understanding what is fire. So fire, most of us think it's a physical happening because of the external things that we see and all the damages that it makes. But in essence, fire is a chemical reaction. It's a chemical reaction because it is a reaction between certain things which causes that pyrolysis or that destruction of a product by a chemical reaction. So we must start understanding fire as a chemical reaction, and it happens when a particular fuel is there. Anything, a fuel can be anything. It can be paper, it can be wood, it can be iron. Anything can burn if enough heat is given. Along with fuel and heat, you need to have oxygen present. Without oxygen, fire is not going to work. And also a uninhibited chain reaction, which is a non-stop chain reaction which makes these three things continuously burn. So when a fire happens in a fire accident kind of a scenario, what the fire extinguishers or the fire service staff are taught to do, they are taught to remove at least one of these three elements, these first three elements, which we call as a fire triangle. You remove one out of them, or two out of them, or all the three out of them, at least one out of them, and you succeed in putting down the fire. That is the idea of fire service staffs working. So they are trained to remove one of these elements. Fire, when we speak of fire, it needs fuel. So usually fuels are gases because they can burn much better than solids and liquids. Even if you burn paper, you must have noticed that paper turns into smoke while burning. That is because whatever you're burning, solid or liquid or whatever you're burning, they turn into gases before they are burnt, and the vapors are what actually burn. So if you're going to burn paper, it takes a little more effort than what it would take to burn a liquid fuel. Take for example petrol. It will easily vaporize, so therefore it can easily catch fire. Paper can take a little more effort to catch fire. Make it wood, it takes even more effort to catch fire because the conversion into gas becomes difficult when you move from petrol to paper to wood. We call it in chemistry as pyrolysis because heat is basically decomposing the fluid, the fuel, whatever it is, petrol or paper or wood. So there is a decomposition because of the heat. So therefore, it's known as pyrolysis, heat lysis, or heat decomposition or heat destruction. So when wood is heated, it pyrolyzes to form hydrogen, oxygen, ethane, and methane gases and methyl alcohol. These highly flammable vapors are the ones which actually burn. This is just one example. Fuel in its vapor form, in its normal state, like say for example a LPG or a natural gas kind of a fuel, it need not be pyrolyzed. It can directly catch fire. And most fuels, they are usually organic compounds with carbon, hydrogen, and oxygen, and they also have traces of mineral material in them. When fuel burned completely and freely in air, the carbon reacts with the oxygen, forming carbon dioxide. Hydrogen reacts with oxygen, forming water vapor. Mineral matter is what remains as ash when we see it. And when all this is happening, oxygen is getting drawn from the air in order to continue the reaction, and heat is thrown out by radiation, convection, and conduction. Fire, the elements of fire, it's understood as a triangle because the three major elements, oxygen, heat, and fuel. Fuel is the one which burns. It requires heat to set fire and it requires oxygen to continue burning. But now we also understand that these three elements need to be in an uninhibited chain reaction in order to continue burning. So now the fire triangle concept is gone and we understand it as a fire tetrahedron. Okay, a fire tetrahedron with four sides: oxygen, heat, fuel, and an uninhibited chain reaction. Anything will burn. It's not that iron can't burn or something solid can't burn. If you notice, iron can also burn in a hot enough chamber. So ironsmiths, when you notice, they burn iron in order to shape them. So if you give enough heat, enough fuel, anything can burn. We usually burn wood, cloth, paper. It can also burn liquids, kerosene, oil, or gasoline. Vapors from paint, gasoline, and other flammable materials are easily they're able to catch fire because they are able to produce a lot of gases, vapors. So anything can burn. Oxygen is required for combustion because without oxygen, fire will not be in that state of combustion. It will die off. Therefore, oxygen is required. But we also need to remember that when fire is burning, there is more amount of smoke and poisonous gas that is produced. So it kind of cuts off the oxygen supply sometimes. Because of this production of smoke and poisonous gas becoming higher than the amount of oxygen that is available, fire can get off on its own also. The next element of fire is heat. We need to give it sufficient amount of heat to any solid particle or a liquid fuel in order for it to burn. Many items that we see in our homes, like our chairs and furniture and metal things, sometimes the combustion temperature that may be required would be somewhere around 400 to 600 Fahrenheit. But some items, say for example your kitchen item, something like a cloth that you have in the kitchen in order to hold the vessel or something, that can ignite very quickly. So we need to be understanding of we need to have that understanding of how things burn, what temperature is required for different things. The final part of the tetrahedron is the uninhibited chain reaction. This is the self-perpetuating capacity of combustion. So it does not allow the combustion to stop. Instead, it keeps uninhibitedly cycling it. There is a chain reaction that keeps happening. Therefore, there is a self-perpetuating capability of that fire, and it's a continuous reaction which ensures that surplus amount of heat is produced, that amount of oxygen is kept available, and also fuel is, if fuel is going to get over, fire is going to go in search of fuel. So it's an uninhibited chain reaction, which is the final phase of the fire tetrahedron, which keeps the fire burning. And all these four elements need to be there. If you're going to remove one, you will be able to put down the fire. There are different stages when a fire burns. So when you light, say example, a garbage heap, it's difficult to make it burn in the beginning, but once it catches fire, it becomes fully spread in fire. Then if you stay back and watch, it slowly dies down, and then it smolders for a long time, and then it finally dies off completely. So there are different stages of fire, and for fire safety, that understanding is important, and they are called as phases of fire. What are the different phases? So four phases: incipient phase, free burning phase, smoldering phase, and a extinguished phase. So in the incipient phase, we also call it the growth phase. So the fire starts to grow. The free burning phase, the fire is in a fully grown state. In a smoldering phase, the fire is slowly decaying. In an extinguished phase, the fire has decayed completely. This is how we understand the different phases of fire. So incipient phase, it's the phase where it slowly starts to burn. There is a growth, like you can see here. So the fire slowly grows in its burning. So the temperature could reach up to even 1000 degree Fahrenheit. Next stage, free burning stage, there is a almost equal amount of burning that is continuing. Fire burns outwards and upwards always. So oxygen is available, fuel is available, heat is available, the fire keeps burning. Then there is a fully developed stage where again it's continuing to burn. Smoldering phase, it slowly starts to decay. The fire slowly starts to cut down. It could be because of lack of oxygen, lack of heat, lack of fuel. It could be any reason. Then it finally decays. It gets extinguished. Sometimes the fire can restart even from an extinguished phase. So fire extinguishers, the fire service people, they know to wait till the fire is totally cut down. We need to understand these stages in forensic science because the color of the flame, the temperature, the wind current, the odor, etc., can be very important in understanding a fire incident. It could help us to understand whether it is a fire accident, whether it is a incidental fire, what happened, we'll be able to understand. So therefore, stages of fire is something that we need to understand. Hope you've understood so far.